Dear me, what are those things coming out of her nares?
Spaceballs?
Oh, shit. There goes the planet.
So first, let's look at the anatomy. So first, let's look at anatomically modern human anatomy. When we look at brain size, we are talking on the order of 1500 to 1600 cc's. And this is similar in size to what we saw for Neanderthals. But some of the derived features include a much smaller face, a more gracile face, and a higher forehead. As you can see here in this chart, in this illustration, Neanderthals have much more of a sloping forehead, along with the very pronounced brow ridges, and both of those are absent in anatomically modern humans. Our most characteristic derived features is a chin, and this is one thing that will distinguish quite readily between humans, anatomically modern humans, and Neanderthals. We have small incisors, which is an ancestral trait, non-taurodont roots, which is also ancestral, and a gracile skeleton. In general, we are taller and more gracile than Neanderthals. We have that large brain, the globular skull and forehead, and then the chin. But one of the things we'll look at this week are actually the behavioral changes that we see with anatomically modern humans that really indicate a great leap forward. So we have the first appearance of anatomically modern humans in the Middle Stone Age, around 200 to 100,000 years ago in Africa. So one of the classic examples of this is the Herto skeleton in Ethiopia, dating to around 160,000 years ago. Anatomically modern human skeletons are found in association with hafted stone tools, so where a stone tool has been attached to a wooden shaft, so you can think along the lines of a spear. We're not at the point where we're talking arrows, bow and arrows, or anything like that. We also find quite a number of bone and antler tools. So anatomically modern humans are heavily invested in modifying their material world. And this is just a reminder that we use the Stone Age terminology for remains found in Africa, but Paleolithic, Neolithic, etc. for those that are found in Europe and the Middle East. So in the Middle East, this is the area of the earliest interaction between anatomically modern humans and Neanderthals, and it takes place in the Middle Paleolithic. We see in these contact sites similar material cultures. Now, it was often thought that Neanderthals didn't really modify their environment like humans, anatomically modern humans did, or that they only began to do so after they had contact with anatomically modern humans. But some of the more recent research that's coming out now is calling this into question and suggesting that Neanderthals were actually producing quite a bit of bodily adornments. So in Israel, we have two sites, Kavza Cave and Skull Cave. At these sites, the anatomically modern human remains actually predate the Neanderthal sites. And so what this suggests is that as anatomically modern humans moved out of Africa, they occupied this area. And then at some point after that, Neanderthals were actually pushed southward, likely by expanding ice sheets, glaciers. So they were in a much colder period, which pushed Neanderthals down to the south, and then anatomically modern humans and Neanderthals were interacting. Anatomically modern humans arrive in Europe around 40,000 years ago during the Middle to Upper Paleolithic transition. And we do see a Neanderthal extinction around 23,000 years ago, but this still means that there were approximately 17,000 years in which anatomically modern humans and Neanderthals were living in roughly the same area. When it comes to the origins of anatomically modern humans, we have the date pretty well set at around that 200,000 mark. But there have been two long-standing and competing hypotheses for how anatomically modern humans originated. The first of these is the multi-regional evolution hypothesis. And this suggests that interbreeding between specialized forms of Homo erectus ultimately led to modern human populations. So, and this is somewhat supported by both genetic and skeletal variation that we've seen in specimens from different regions, but there are some underlying racial tones to this argument that have been problematic as we have explored it and looked at human variation as a whole. Now, specifically, this is arguing that Homo erectus, who left Africa initially, spread out into Europe, Eastern Asia, Australia, etc., and developed different specialized forms like Neanderthal for Europe, Peking or Java man in Asia and Australia, and that eventually the interbreeding between these various species has led to unique geographically based human populations. So if we think back many weeks at modern human variation, we also know that the similarities between humans in different regions is much greater than that the differences between them. At play for the origins of anatomically modern humans is what is known as the out of Africa hypothesis. And this really proposes that anatomically modern human populations originated in Africa between 200,000 and 160,000 years ago, and eventually left Africa to populate other parts of the world. And this one is highly supported by both genetic data and the fossil evidence that we have. Now, the third theory that you'll read about in your book is the sort of hybrid hypothesis between the multi-regional evolution and the out of Africa hypotheses. And this encompasses some of the more recent evidence that we have for interbreeding between humans and Neanderthals, and also the existence of the Denisovans, who are still sort of an enigmatic Asian species. Now, when we look at the evolution of anatomically modern humans and the expansion worldwide, one of the important things that we have to consider is the impact of historical contingency on human evolution. Now, specifically, I'm talking about the eruption of Mount Toba in Sumatra around 70,000 years ago. You might have heard the phrase that more variation exists within human populations than between them, particularly that more variation exists within populations in Africa than anywhere else in the world. And this is in large part due to the Mount Toba eruption. It caused a genetic bottleneck by reducing human variation in the populations that had already left Africa at this time. So we see much more genetic similarity in the populations that exist outside of Africa than we do even within populations within Africa. Now, a couple of important behavioral changes associated with anatomically modern humans. The first of these relates to settlement patterns. Now, when we are looking at the Middle Paleolithic with archaic Homo sapiens and Neanderthals, we see very little evidence of buildings. People were making habitations in rock shelters, really just taking advantage of the natural geography that existed and the natural shelters that existed. They were also opportunistic foragers, so they were taking advantage of the herd animals or other animals that existed within a geographic territory rather than necessarily searching out other species. When we look at the Upper Paleolithic and modern Homo sapiens, we see new evidence for purposely built structures, such as the one depicted here made out of mammoth bones. We also start to see evidence of seasonal rounds and logistical collecting. So people were moving across the landscape in order to take advantage of different resources. We also see an expanded tool repertoire that includes blades. Now, the definition of a blade is a stone tool that's twice as long as it is wide. And this is a much more efficient use of the raw stone material, and it also gives a more efficient, sharper and longer cutting edge of the tool. These different blade technologies are grouped into different types based in large part on the temporal period. Now, the names of these are not as important as the fact that they existed, and we see different technological developments and variation in time and space that is kind of riffing on this basic stone tool technology. One of the other really important things that we see with anatomically modern humans is the collection of raw materials from very far away. So, for example, at this one site in Russia, we find obsidian that came from 186 miles away. Now compare this with what we read about for Neanderthals, who were using the resources that existed generally within 5 kilometers of their home base. So Neanderthals, they are located in one place, and they utilize the resources that are available to them there. Anatomically modern humans, though, are sourcing materials from extreme distances. And this doesn't just indicate that they were going out and purposely seeking certain resources, but this also suggests that there were underlying social relationships that facilitated this, that facilitated long distance interaction and trade. So the sociality of anatomically modern humans is a big step forward over what we have traditionally seen for Neanderthals. Around 30,000 years ago, we have the invention of the spear thrower. This is commonly known as an atlatl. And in this, a hafted spear, so stone tool on a spear. In modern humans, we also see a number of other technological innovations. One of these is the invention of the spear thrower, also known as an atlatl, around 30,000 years ago. Now, this works by creating a stick, a base, to which a spear can be hafted or kind of slotted in. So in this image, looks like a buffalo or some other type of herd animal. At the back, the end of the spear would kind of notch right onto the nose there, and the person would hold the front end and balance the spear, reach backwards, and then toss, kind of like tossing a baseball. And this gives a lot of extra power and accuracy to a throw. Along with this came a much broader diet of different herd animals, but also, smaller animals and various plant collecting as well. There tends to be a slight archaeological bias towards hunting, what we call the stones and bones bias, just because of the preservation that occurs. So stones and animal bones preserve much more readily in the archaeological record, whereas plant materials or nets, basketry, those sorts of things are harder to preserve. But we do get some evidence of this, and nets point to collection of both small mammals as well as fish. And then we also find evidence for tubers, so various things in potato or yam family, different seeds, fruits, nuts. An expanded material repertoire working bone and shell, both for tools and also for adornment. We find evidence for sewn clothing, both from the tools that were made to use it, that were used to make it, such as awls, punches, and needles. And the ability to create clothing really expands the environments that anatomically modern humans could live in. These adornments are also used for self and group identification. So we again see an increase in the sociality of anatomically modern humans. And some of these objects, these non-utilitarian objects, so decorations, may have been used to signal status or social hierarchy within a group. We also see much more elaborate burials and burial offerings with anatomically modern humans. And finally, we start to see the production of art. And this type of symbolic expression is unique to the anatomically modern humans, and I would argue is the thing that really differentiates us from other archaic human species. Some of the first artwork is from 77,000 years ago in Blombos Cave in South Africa. We have both polished bone tools and incised ochre objects. Ochre is a mineral that was often used to to color things. It was a mineral pigment. Here at 28,000 years ago, from the Apollo 11 cave in Namibia, we have image of a lion. And in Europe, we have some really fabulous examples dating to around 36,000 years ago of what we call parietal art, or cave painting. These include both abstract images of geometric designs, and then more realistic images, such as those in Chauvet Cave and Lascaux. Now, this video I'm actually going to link to in Blackboard rather than playing it through the PowerPoint here, but I really recommend you look at this for some of the new research that's coming out about these parietal drawings. We also have what is known as mobiliary art. So these are objects that include carved statue, inscribed bones, antlers, ivory, and these were objects that were meant to be carried around. So the La Marche antler, dating to about 15,000 years ago, is one of these classic examples. The variation in the size and positioning of the holes there has been suggested to represent the lunar path, the path of the moon through the sky and the various phases. Now there's a couple of interpretations that can be made from this. One is that it is a calendrical device used for marking herd movements. The other, of course, is that it follows another cycle that is related to the moon, and that is of the female menstrual cycle. We also see evidence of female fecundity in other types of art, such as the Venus figurines, the Venus of Willendorf and the Venus of Hohlfels. These figurines emphasize various fertile characteristics of the female form, like breasts, hips, and buttocks. Larger hips, buttocks, or breasts often indicate greater fat stores and greater fertility. So what did all of this art mean? Well, it means a much more socially rich environment. It represents greater cognitive development and cognitive capabilities, and really is, again, the thing that differentiates anatomically modern humans from the more archaic species.